Hello class, this is Dr. Vev and I'm here to discuss the solutions to sample test number 2. This is the same test that's already up on my website as well as several other instructors' websites. So let's start by going over this test. The first section is multiple choice, and the first question asks us what is the unit joule equivalent to. So there are a couple ways to do this. One is to take the work done by a force, WF. It's something like F dot D. And so the work done is the same as joules in units. That's going to be newtons times meters. Well, that does not look like any of the answers, so we may have to break it down further. Newtons is kg meters per second squared, and times a meter, so that means kg meters squared per second squared is the right answer. And there's another way to do this, and that's using kinetic energy. But the work kinetic energy theorem says that work and kinetic energy are the same thing. So kinetic energy is 1/2 mv squared. And so the units of kinetic energy are also going to be mass kg and speed meters per second squared. So that's another way to find the units. The next question asks us the work done by a particle. So this is exactly that definition right there. We have to use a dot product. So the dot product of the displacement here is just delta r. So the dot product is going to be the x component of the force times the x component of the displacement plus the y component of the force times the y component of the displacement and the z component of the force times the z component of the displacement. You will notice that there is no z component for the displacement. So that's 0. So we just have to worry about these two terms. Fx is 1. I'll just omit units for now. Delta x is 30. Fy is -2. And delta y is -10. So if you do the math, that's going to be 50. Next question is a knowledge question, which means that you either know it or you do not. A force acting upon a particle is called conservative if the correct answer is this. Force is called conservative if its work done is independent of the path between 2 points. So if you have a random path between 2 points, and let's call that the initial and then that's the final, and if you have a particle doing force acting on a particle between these 2 paths, if it's a conservative force, it will only depend on the displacement d, and the conservative force can be it'll be different things in different places, but at the end of the day it will only depend on the actual the initial and the final point, and not on the details of the path taken. That's one of the miracles of conservative forces. The object moves in a circular path at constant speed. So the reason, first of all, they tell you that the work done is 0. And then they ask you for the various reasons, and you have to pick one. The reason it's 0 is really because the centripetal force, whatever that force might be, let's say it's tension. If you're whirling around a object, it's a tension, let's say, at constant speed. Then with a string, you're doing something with a string, then that'll be the tension, is the centripetal force, and the displacement is going to be perpendicular to that. So that's the reason why the work done is 0. Let's go on to the next few questions. Now I'll be doing this video in 2 or 3 parts. I'll do one part for the multiple choice questions and a couple other parts for the short answers, just to keep the size of these videos manageable. Question 5 is a work done based on the integral definition of work. So the work done by a force is also equal to the integral of f dx, f dot dr, and that's the area under this curve, because that's the geometric interpretation of the integral sign is that it's the area under the curve. So we just have to figure out the area here. So that's a triangle of positive area, and that's a triangle of negative area, and we just have to put those two areas together to solve this problem. So this triangle has got area 1/2 times the base, which is 6 minus 2 or 4, times the height, which is 20. So the positive area is going to be 40. What about the negative area? That's 1/2 times the base, which is 8 minus 6 or 2, and the height, which is negative 10. So the negative area is just negative 10, and when you put them together, you get 30 joules as the answer. The next question is a question about finding the force given the potential energy. Now here the relationship between the two quantities is F equals minus du by dx. That minus sign is very important because there are two answers, one which you get without the minus sign and one which you get with the minus sign. So that minus sign is kind of important. So that gives me negative kx, negative mg, and 5 as a constant. Next problem is center of mass of this figure. Now observe that each of these squares is a uniform object, so each of these squares itself has got the center of mass right in its middle or midpoint. So one way to solve this problem is by using symmetry. So this the coordinate of the first point is going to be L over 2. So I'm just going to label these points. Let's call this A, B, C, and D. So for object A, the coordinates of the center of mass are going to be L over 2, L over 2. For object B, it's going to be L over 2 plus L, basically. So that's 3L over 2, 3L over 2. For object C, it's probably easier to subtract. So that's going to be 3L minus L over 2, or 5L over 2. This is comma L over 2. And this object D is going to be located at 3L over 2 this way and 3L over 2 that way. So now we just have to put it together. The center of mass XCOM is going to be the masses are all the same, so I'll just call it M. It's M times the x coordinate of A plus M times the x coordinate of B plus M times the x coordinate of C plus M times the x coordinate of D divided by the total mass, which is 4M. So the M's cancel out, and I'll get 3L over 2 plus 3L over 2 is just 3L. 5L over 2 plus L over 2 is again 3L. So that's going to be 6L over 4, and that's 3L over 2. The YCOM, by a similar calculation, is ML over 2 plus m times 3 L over 2 plus m times L over 2 plus m times 3L over 2 divided by 4m. So that's ml plus 2ml or 3ml. The m's cancel out, so it's just 3L over 4, and that's that. You can't simplify that any further. So the answer is 3L over 2, 3L over 4, which is the answer C. Let's go on to the next one now. A block is given an initial speed v and then moves across a level surface. How far does it travel? So there are many ways to do this, but since this is an exam testing work and energy, let's use those ideas. The work done by the force is equal to the change in the kinetic energy. So but they want you to find how far it travels, so we have to also break down the work done by the force. Now if you have this object, its free body diagram looks something like this. Here's the normal force, and here's gravity, and the two are equal because the block doesn't fly. And then you also have the force of friction acting to the left, force of kinetic friction, and then the object's moving to the right, accelerating to the left, and its displacement is what we're trying to find, L. So the work done is just, you can see the angle between the force and the displacement is 180 degrees. So it's going to be force of friction kinetic times L times cosine 180. The final kinetic energy is 0, and the initial kinetic energy is 1/2 mv squared. Now cosine 180 is -1, so that cancels the negative sign. So force of kinetic friction is just mu times the normal force, and the normal force is mg. So we'll write that here. Substituting that, I get mu k mgl equals 1/2 mv squared. You notice the mass cancels, and that gives me the answer, v squared over 2gl. Well, 2 mu kgl, mu kg, and that's the value of L. So the answer is D. Okay, next question. 5 kg object is acted on by a net force in the x direction, and they've given you the work done. Power is how much? Well, the power is given by the work done by the time taken. So we just have to divide those two things. 600 joules over 6 seconds, and that's 100 watts. The ball of mass m strikes a massive wall at speed v0. It bounces off the wall. It's in contact for a time t. What's the magnitude of the impulse? So here we have to use what's called the impulse momentum theorem. The impulse momentum theorem says the impulse is equal to the change in momentum. Now you notice that the x velocity does not change. Well, the y velocity does not change because it's the same speed, and the y direction, the velocity doesn't change. So the only impulse is in the x direction. So jx is going to be the change in the speed of the x direction. Now this is positive because that's the coordinate I hat in that direction. So this is going to be positive. If this is v and if that's m, the x component is v cosine theta. So the impulse is the finals. So that it's going to be here in this direction. It's going to be negative. So that's negative mv naught cosine theta, and the initial one is going to be positive mv naught cosine theta. So that's the impulse applied by the wall. So that's minus 2 mv naught cosine theta. And you notice that the impulse is negative. It merely means that the wall is exerting that impulse in this direction. But since they want the magnitude, we don't worry about that negative sign and just circle the answer. Okay, moving to the last 3 questions on the multiple choice section of this exam. A ball of unknown mass is thrown off a building with some height at unknown angle. What's the initial speed of the ball, ignoring air resistance? And the best way to solve this is the work kinetic energy theorem. So the work done by gravity, which is the only force acting here, assuming you don't have air resistance, which is the case, is the change in the kinetic energy. Well, even though the ball is going in a complicated fashion, remember that gravity is a conservative force, and here's where the idea of conservative force really helps you. So the force of gravity is always acting down, and the displacement is going to be in this direction, displacement. So the work done by the force of gravity is just Fg times the displacement in the x, Fgx plus the displacement in the x direction plus Fgy times the displacement in the y direction, and that's equal to the change in kinetic energy, which is 1/2 mvf squared minus 1/2 mvi squared. Now gravity does not have an x component, so that's 0. So this is just mg. The displacement in the y direction is just the height. So that's mgh equals, and you notice that the displacement in the y direction is downward and the force of gravity is also downward, so the two negative signs cancel out and you just get mgh. It's equal to 1/2 mvf squared minus 1/2 mvi squared. Cancel out the mass from everything and you get vi squared. If you bring this vi squared over to this side, vi squared is equal to vf squared minus 2gh. I've also multiplied through by 2, and then I just take the square root, so the answer is B. The next question asks us to find the speed of an object if it's acted on by a force which varies with time. So the governing principle here is impulse. The impulse is f dt between 0 and 3. This is going to be 3t squared dt in 0 and 3. The integral of 3t squared is t cubed, and that's just 27 Newton seconds. But that impulse is also equal to the change in momentum, so that's going to be the mass times the final speed, velocity actually, minus the initial velocity. So these are all vectors, but it's one dimension, so I'm not writing the vector sign, although I should probably do that. Positive is the vector direction here. The initial speed is 0, velocity is 0, so this gives me, and the impulse is the same as the change in momentum by the impulse momentum theorem, so I get 27 Newton seconds is equal to the mass, which is 9 kg, times Vf. So Vf is 3 meters per second, because 9 and 27, you get 3 from that. Last question is a principal question. How do you find the final compression of the spring? So the idea is, after this falls, when it just touches the spring, it's moving pretty fast, and then it starts slowing down as it compresses the spring. Well, we don't really care about all that. We'll just look at the final situation. When it finally stops, the compression which they call Ym. How do you find that? Well, again, the best way to solve this is the principle of energy conservation. If you call this the initial and if you call this the final, the total mechanical energy initial equals total mechanical energy final. Initially, it just has potential energy. Its potential energy is just going to be mg. If you take this to be the potential energy 0 down here, it's just going to be mg of h plus ym, because that's the height of the mass. And then this is here it's going to be the total mechanical energy final will just be the spring's potential energy, and that's going to be 1/2 k ym squared. So the answer is D. This is a quadratic equation, but they're not asking you to solve for ym. They're just asking you what's the equation you need. That completes the multiple choice portion of this practice exam. I'll continue in a couple other videos to do the long problem answers.